The next topic we're going to get into here is domain and range. A very short, simple, easy definition for domain and range. Domain can be thought of as the set of all your x values. Just what x's is your function using. Range is the exact same thing, but opposite is the set of all your y values. Just what y values is your function using. Let's take a look at this first set of problems, finding the domain and range of each function. If you are given a table and we are looking for the set of all of our x values, we just need to look at what x values are listed in the table. And that's your answer right there. If we are looking for the range of our table, same thing. The set of all the y values, we'll take a look at all the y values in the table. And that's our range. Same rules apply for a set of ordered pairs. I go ahead and challenge you to go ahead and pause the video and try this one out real quick on your own. So same thing, domain is all of our x values. So we will take a look at all of the x values in each of those ordered pairs, and that is our domain. Ordered pairs are not a continuous function, so we don't have to write out domain and range using inequalities. Range, taking a look at our y values this time, and writing them out. And we are done. Domain and range. It gets a little more complicated when we are looking for it in a graph. I want to do a quick reminder of our inequality symbols. If you see a closed circle, that means that the number that it represents is included in our inequality. And that's where we use these symbols, our less than or equal to symbol and our greater than or equal to symbol. When we see an open circle on our graph or written in an inequality, that means that number there is not included in our solution set. So we use just a less than symbol or just a greater than symbol. Okay, so let's take a look at this graph. And we're going to be identifying the domain and the range. So, like we said earlier, domain is all of our x values that our graph is using. Range is all of the y values that our graph is using. We can think of domain and range for graphs as measuring our graph. For domain, we will be measuring left to right. Okay. Same way that our x-axis goes for domain. This is our x-axis. Our x-axis moves from left to right. For range, we will measure our graph from bottom to top. Same way that our y-axis moves from bottom to top. Okay. When we write these inequalities, we will always go left to right, bottom to top, small to big, negative numbers to positive numbers. So let's take a look at our graph and try to measure it. Try to find all of the x values and all of the y values that our graph uses. So again, domain, measuring left to right, how big our graph is left to right. I see that my graph goes all the way on the left to -1. And I see that moving right, my graph goes all the way to the right and stops right there at x equals 2. So I will take both of these values that my graph goes to on x, -1, all the way to 2. Domain measures x. And I will go ahead and fill in my inequality symbols. Remembering that a closed circle would mean or equal to, I would need to add that line, and an open circle does not need the line under it. Okay, our circles on our graph happen to be open, so I am done. Let's go ahead and do the range. In this case, we are asking ourselves how tall our graph is. Okay, range, bottom to top. We're looking at our y values here, up and down, and measuring how tall our graph is. Seeing how low our graph goes. Seeing how high our graph goes. In this case, bottom to top, my graph ends here at y equals 0, and it goes up to y equals 2. Okay, from 0 all the way to 2. Range is measuring y values. I'll go ahead and fill in my inequality symbols, and then double check the circles on my graph, the endpoints, checking if they are open or closed. In this case, they are open circles, so my symbols are good. They do not need lines under them. Okay, but what if our graph does not have endpoints? What if it has arrows, like this one? The linear function graphed at the right. What do the arrows on each of the line suggest? These arrows mean that our graph goes on and on forever and ever. It does not stop there. This graph goes on forever and ever off the page in both directions. So if we tried to find the domain of this function, we tried to find how big our function is from left to right. At first, it looks like on the left, our function stops right here at -8. But that's not true, because this arrow means that our graph would go on to the left forever and ever and ever. Okay. Forever and ever to the left, our math word forever and ever, infinity. And to the right, same thing. It looks like our graph stops at a +7 to the right, but it doesn't. There's this arrow that takes it further and further, forever and ever to the right, all the way to +infinity. Another way to say from infinity to infinity in math is to say that our domain is all real numbers. And the same thing applies for our range. If we take a look at how tall our graph is, at first, it looks like our graph stops down here at -2. But it doesn't. This arrow takes it down further, all the way to -infinity. And if we look at the top, at first it looks like our graph stops at a +6, but it doesn't. It has an arrow that takes it higher and higher, all the way to +infinity. And again, when we're going from negative infinity to positive infinity, another way to say this is that our range is all real numbers. A good way to remember this is when you see arrows on both ends of your graph pointing in opposite directions, your graph is going forever and ever up, down, left, and right. Your domain and your range are all real numbers because we see those arrows in opposite directions going up and down, going up, going down, going left, going right. Domain and range, all real numbers.